Hello students. So today I am going to discuss about the vector integration. In all your previous videos you people have studied about the vector differentiation, that is the first unit of the vector calculus. This is the second unit, that is the vector integration. So in the vector integration what we have a first concept, vector line integral. Okay, so what is the meaning of vector line integral? Observe here, consider a curve C in a space. Consider a curve C in the space which consists of a infinitesimally small line elements of a length dr. Observe here, this whole curve is splits into small elements of a length generally dr, but when it is divided into small element, then the length of the each element is represented as a dr1, dr2, dr3, so on up to drn. Then the line integral of a vector A of xyz along the curve C is defined to be the sum of the scalar product of vector A and dr. We are going to find a line integral of this vector function along the given curve C and is defined to be the scalar product between a vector A and dr. Okay, the definition involves here the scalar product or a dot product. Scalar product, it is also called as a dot product also. So the dot product between vector A and dr under the integral over a curve C or a path C. Okay, so this is called as here line integral of a vector A of xyz, where dr represents here dx into I plus dy into j plus dz into vector k. So how it becomes this whole term? We know that vector r is nothing but xi plus yj plus zk. So differentiate on both sides, then it becomes r will be dr equals to x becomes dx into I, yj becomes dy into j plus zk becomes here dz into vector k. So this is all about the line integral definition, vector line integral definition. Next we have an important point. If a C is a closed curve, then the line integral around C is denoted as integration of vector A dot dr. Okay, integration of vector A dot product with dr over a closed curve C. This is the symbol to represent the closed curve. So this is also generally this curve may be this curve is maybe a square, rectangle, or a ellipse, hyperbola, parabola, like that. But here closed curve, we have a closed curve. So closed curves are nothing but rectangle, square. Okay, so those are the examples for a closed curve. If such type of curve is there, we are going to find here line integral of any vector function under the closed curve, then we have to use this symbol. So integration of vector A dot dr over a closed curve. Okay, so this is the denotation of a line integral, vector line integral for any curve here. Okay, this is for a closed curve. And here we have an example. This is the physical example for the vector line integral. What we have observed here, consider a path AB. Okay, consider a path AB. So in that, if a particle P moves from A to B under the force F, if we apply a force to this particle, then it moves from A to B, in the direction from A to B, and its displacement is denoted as here dr. A particle displacement is denoted as here dr. Then we have to find here work done by the force. We have to find here total work done by the force. So on that time we are going to use here line integral formula. What is that? W is equals to integration over a curve C over a path AB, that is denoted as here curve C, vector F dot dr. Dr represents here displacement of the particle. Vector F represents here force acted upon a particle here. So this is all about the examples, physical example of the vector line integral.